Okay, so here we're going to take a look at the trapezoidal rule. So in the previous video, we looked at the midpoint rule. And now we're going to take a look at the trapezoidal rule, and it's based off finding areas of trapezoids as opposed to rectangles, right? So let's take a look here. A trapezoid is an example of a type of trapezoid where we have two parallel lines, right? Exactly a pair of parallel lines, right? And we call these the bases of the trapezoid, right? Now to find the area, if we call this base 1, base 2, so the area is essentially the average of the two bases. So base 1 times base 2 times the height, right? And the height is the perpendicular distance here between base 1 and base 2. Now, in terms of our integrals, right, what that's going to look like here, this is my f of x, right? I'm going to, again, divide up my interval from A to B, right, where A is my x naught, and each is delta x change, right? No, excuse me, x0, x1, x2, etc. till we get to xn. All right, and then here, this one is x sub n minus 1. All right, now in terms of here, my function and the shape that I'm going to make, so what I'll do is the endpoints of the intervals, I'm going to use those to form my trapezoid here. Now what we're going to notice here is that here, right, the parallel lines are these lines that go straight up here, essentially from the value of the function to the x-axis. Right, so those are going to be my bases, right? We're kind of looking at it sideways here, right? And the height is going to be the delta x, right? So here, if I draw one of these, that first one here, draw it out the side here, right? These are the parallel bases, and we have, right, like f of x1, f of x0, right? The y value, the output value, those are the bases, right? And the height, since this here, notice here, this is the straight line distance between f of x naught and f of x1, well, that is delta x. So as it turns out, these area of the triangle can be written as f of x, and just to keep it general here, x minus 1 plus f of xi, right? Just two consecutive values of the function divided by 2, and then times the height, right, which is going to be delta x. All right, now what we'll notice here, if we want to find the trapezoidal of n, right, adding up all these, right, so what will happen is what that would look like is delta x, all right, so that's the height, and then the sum of the bases, right? If we start at x0, then x1 over 2, then plus delta x and f of x1 plus f of x2, right? Looking at our graph here, the second one would be here, right? So one of the bases is shared from the previous trapezoid. Oops, here we go. Something like that. Okay, over 2, right? And we're going to have that same kind of pattern where for the next trapezoid, we're going to have delta x over 2 of f of x sub 2 plus f of x sub 3. And we're going to continue doing this, right, over 2 here, where we'll have f of x sub n minus 2 plus f of x sub n minus 1 over 2 delta x. And then lastly, till we get to the end, f of x sub n minus 1 plus f of x sub n over 2 delta x. Right? And what we have here is that if you notice here, well, first of all, just to kind of write it a little bit more compact, I see that they all have a delta x in common and they're all divided by 2. So I can factor that out. And one thing that we notice here is that each one of these function values shows up twice, right? F of x1, f of x1, f of x2, f of x2, etc. The only ones that don't are the first one, right? Our starting point, which makes sense, right? If you look at how we're graphing these. This base 1 only shows up in the first one, and the last one, x sub n, right, only shows up once. So we can kind of reduce this formula to be f of x sub 0, which is just the value of a, the beginning point of our interval. Then every other subinterval inside, the function value shows up twice. Here plus f x sub n minus 1. Excuse me, that's 2. And then the last one being the value of b shows up only once. All right, so this is our trapezoidal rule, right? So we want to find t sub n. This is the formula we're going to use. And again, delta x is the length of the interval divided by the number of boxes you want to use, or trapezoids, I guess, no longer rectangles. And each of these x sub i's can be found by using the formula a plus I delta x, right? And really all this means is that if you can just use a recursive formula where you just keep adding the delta x to whatever the previous term is, right? That's just the more explicit form, where if you want to find what is x sub 2, you can easily just plug it into this formula here. But really, in practice, we just start with a being the first one, and then we just keep adding delta x to get to whatever the next point is going to be, right? For example, right, let's say use the trapezoidal rule with n equals 5 to evaluate the integral from 1 to 2 of 1 over x dx. All right, so we start off, our delta x is going to be 2 minus 1 over 5, so we get 1/5, which is 0.2. Excuse me. Okay, and then for each of our x sub i's, so x0, so we'll go from 0 to 5, right? That's just simply our starting point of our interval, which is just 1. And our x1 is simply 0.2 added, right? 0.2, x2, 1.4, x3, 1.6, x4, 1.8, and x5 is 2. Okay, all right, and now to evaluate the integral, so from 1 to 2 of 1 over x dx. All right, so I'm going to approximate it by the trapezoidal rule, where n is 5, so we have, it'll be 0.2 over 2, right, f of 1 plus 2 f of 2 plus 2, oh, excuse me, getting ahead of myself. F of 1 plus 2 f of 1.2 plus 2 f of 1.4 plus 2 f of 1.6 plus 2 f of 1.8, and lastly plus f of 2. All right, and that is the setup of the trapezoidal rule, right? And again, from here, right, no need to do this by hand. Let's just kind of go ahead and use some help here. So here, let me set this up properly. So it was 1 over x And then we're going from 1 to 2. Zoom in here. All right, so that's what the part of the graph looks like, right? And just the overall 1 over x is just the curve kind of going towards there. And number of subintervals, we want 5. Okay. And what we're looking for is the trapezoidal rule. All right, there we go. All right. And we see this here. So that's what it looks like, right? And notice here there's less, you can't really see any white space here that would look kind of signify error. So now we can right away see, oh, this is it'll be a much better approximation doing it in this way. Right, and we can see the result here is 1753 over 2520. And then whatever the decimal approximation is to that, right? Again, important part here is just kind of setting it up, right? Making sure we know what this looks like, and that is an example of the trapezoidal rule.